Hello everyone. So in this is the second part of my first video, operating system. In this video, we will talk about misconception about multi-threading, context switching, race condition, and deadlock. So let's talk about something misconception about multi-threading. So let's see. First of all, if your program runs slow, then multi-threading is not a always option to make it faster. Okay. So multi-threading can make your program faster. It may also make it slower. So yeah, so let's talk about context switching. What is context switching? So context switching is a process in which one thread basically it's switching thread to another process. So let's see how it is working. So suppose we have either core CPU core, okay, and here we have a program thread. So suppose thread 1 is working on a core 1, okay. So thread 2 wants to run on core 2. So what will it take? So now thread 1, now prompt to thread 1, it saves some info known as context, okay. So it will save its contact in a save somewhere such as program counter, okay. So this is the program counter which store the instruction of on working in what instruction it's working on. Suppose I am writing a code on it's working on a line number 14, so it will store line number 14 instruction in the program counter, okay. After that it will instruct address where it is left, it will the store in the stack pointer where it will left, okay. So after it will thread T2 when done with working in core 1. So suppose thread 2 is working, now its work is done. Now it will resume the process again, okay. So now it will resume the process again. So it will load the instruction. It will again load the thread 1 instruction, basically the line number 14, which is working previously, which is basically shut down, okay, due to thread T1 wants to work on the core 1. So it will again load the instruction which you are working on it. So the CPU spends some time in context switching. So this is what I am gonna say. Multi-threading is slower than single-threaded program. Okay, so this is the important part. So this is basically a workflow how this is working. So suppose we have a thread one is working. So this point one is representing here. So what is one? Thread one is working. Second point, thread T2 wants to run on the core one. So now third point. So now thread T1 store the context. Okay, store it context. Suppose there are the context instruction. Okay, all the instruction it will store. Now fourth point, thread T2 loads and run. Again thread T2 ends. Again thread T2 ends. After that sixth point is thread T1 loads the context, rerun where it's left. Again it's reload into the core one. Okay, so in this switching the thread from thread T1 to thread 2, saving the context and loading the basically loading the context of another thread, it will waste some CPU cycle. Okay, so here core is not working. So this is the main point of the context switching. So cache get polluted due to multi-threading program. Locality of a reference of a program is very high. What does it means? Basically program tends to access same set of memory again and again. Suppose here, so thread 1 is basically working on some memory. So after the thread 2 it will free that memory, and when the thread T2 done its work, it will again load the thread T1 instruction. Again it will access the same memory. Okay, so that is what that is mean. So let's talk about multi-threading, which is basically a part of that, not a misconception. So multi-threading makes the behavior of the program unpredictable. So let's see one example of that. So yeah, this is a code. Let me explain it first. let me, yeah. So first of all, we have to include IOStream for input output and thread for the basically thread dot all the thread operations. So here in main we are creating thread T1 and thread T2. So let me draw here. We are creating a thread T1. We are creating a thread T2. Okay. So this join function is basically when the two threads are working, completes working, it will again synchronize the process. So it will return a single thread. Okay. So now, so thread T1, thread T2, this is a what we can say argumentation call in threads. There are basically three type, and one of them is this way we can call. Okay. So yeah. So in which we are passing a function and a parameter one. So this function will be called including the argument which is a variable. Okay, integer x. So what will it do? It will take this integer and basically I am printing this integer inside the thread. Okay, so basically inside that function I am printing this integer. So also I am printing the thread ID. Okay, so for make it bit uh, differently act differently, so I am also printing the thread ID. So let's try to run this code and see the unpredictable behavior of the thread. So first of all, it's working correctly. Let me rerun it again. Yeah, it's also working correctly. Yeah, see here. So now this is the behavior what we are talking about. So this is unpredictable behavior. Okay. So what this thread is doing here, what is printing here, let me explain it. Yeah, so let me try to explain this, what the thing is doing here. Suppose we have a core 1, here we have a core 1, we have a program, we have a program. Okay, in this program is make a thread T1, which is our main thread. Inside that thread we have created a two thread subthreads, thread T2. Okay, so what this is a thread 1, and inside that this is a thread 1, this is a thread 2. Let me rub this. Yeah, so this is the main thread. So what is happening here, basically thread T1 is working on core 1. So after some time thread T2 wants to work because it is not synchronized. So thread T2 wants to work on. So it will stop working on thread 1. It will the core 1 is acquired by the thread 2. So what is happening here? So first some part of the thread 1 is printed. After that some part of the thread 2, here it is thread 2 is printing some part. Okay, again thread 1 is start, again thread 2 stop, thread 1 start executing on core 1. So again it will printing something and something here. So this is how it is the unpredictable behavior of the thread. If I run again, sometime it will give me correct answer, sometime it does not. So yeah, you can see here it is again printing the correct value, and if I run it again, it will again give me some unpredictable nature. Yeah, you can see here. Yeah, you can see here. Actually, I am executing thread T1. Now here it is executing thread T2 first. So this is the unpredictable behavior of. Okay. So this is how we can see. So let's move on to another topic. So yeah. So multi-threading makes the program harder to debug. Okay. So since the what we can say behavior is unpredictable, so it is harder to debug. So we will run into some race condition. Okay, so we can see an example. Two operators are happening at the same time, attempts to access the same resources at the same time. What basically the race condition is, meaning of race condition is this. So we can take an example. Suppose in our some of our Indian houses we have two switches for the same light. Okay, so suppose if we switch on this light and this switch is switched off. Suppose we switch off this light, it will be again switched down for this switch. Okay, so this is how race condition works. We have also deadlock and starvation in multi-threading. So let's talk about some of the conditions. So this is the example I already showed how this basically unpredictable nature of this is our main thread. This is executed by thread 1, this is executed by thread 2, which I defined here. So this will give me some random answer. Okay, this shows me unpredictable behavior. So let's talk about the race condition. What is race condition? Let's see one example also for the race condition. So yeah, here is my race condition. So let me explain it first what here it is doing. Yeah, it is fine. So let's start with this code explanation. So first of all, we include these header files ISTM and thread mutex. Let me just be forget this line. So yeah, I have here make a shared variable. Okay, globally declared. Okay, globally declared variable. Inside our main function, I created a thread T1, thread T2. Okay, after this I will combine. Join basically is used to synchronize after the thread executed. Okay, so after that, inside that thread we have passes function. So what this function do is basically it will run a for loop for me to from 0 to 1000. Okay, from 0 to 1000. So basically it will increase my shared variable. So this is what we call, yeah, for some time I will sleep my thread for 5 milliseconds. Okay, so let's what this if I run this code roughly. So what this gonna look like? Thread T1 firstly execute. So thread T1, its share variable will be 1000. Okay, my shared variable value, let's say it where, okay, my shared variable when thread T1 runs, it will increment it to 1000. So what I gonna say, 1000 plus 1000 one by one, basically 1000, then again it will, and it will go to 1001, it will again go to 1002. So one by one it will increase up to 2000. Okay, so now after that thread T2 runs. Now the shared variable will be 2000. At 2000 it will again run 2001, 2002, so it will up to 3000. So my expected output will be 3000. So let's try to see what my output is. So let me choose language first. Yeah, so it means sharing same it will, yeah, here you can see it will giving me 2999. So I am expecting 3000, but it's giving me 299. Sometime it's giving me right answer, sometime it's giving me wrong answer. Let me rewrite it because of the basically unpredictable nature of the thread. So again it will give me right answer, wrong answer, as you can see, right answer. Again it will change the value, it will change to 2998. Okay, so why this is happening? So why this is happening? So because we are sharing same memory location for the two different threads. Okay, so before because we are not locking this memory for the thread 1, let's see what is happening here. So let's see. So yeah, we have a shared variable which having a value 1000. Okay, so we are running thread 1 and thread 2 parallelly. So what this gonna do, in thread 1. So this is basically, yeah, in thread 1, what is gonna do, it's read the register 1 for 1000. Okay, it will go into the for loop, it will go into the for loop. Okay, for the function, inside the function fun, here I can show you once again. So yeah, this is the function. So inside that for loop, first it will increment to 101. Okay, 1001. Okay, it will increment for the first time. After this increment, the thread T1 stop working. There are multiple possibilities at which it can stop. For showing me less, I am stopping at 1. Okay, so again, before uh, thread T1 writes it to the shared variable, it acquired by the resource. The resource is already acquired by the thread T2. It's read the memory as 1000. Okay, before thread T1 write into the shared variable. Okay, so here it is write, here it is read. Okay, so before writing it's read 1000. Okay, after that it will again run on the same function for loop. Okay, it will increment it 2001 and write it as a shared variable 101. So now my shared variable value will be 1001. Okay, so what the error is, basically interleaving of instruction might occur. So what does is happen if I run this code? Suppose thread T1 runs 1001, it will write. So my shared variable will be from 1000. Thread 1 read and write it to the 1001, again read and write. Okay, thread 2 what will it do? It will read it 101 and it will read it right, and it will be 102, but my output is it's stored in 101. So this should be 102. Due to the race condition it will fails. So this is how the architecture looks like. So there is a L1, L2 and L3 caches. So basically L1, L2, L3. So L1 is basically the faster and the efficient storage, which is in smaller size. It is slightly greater than, as you can see. Let me open my, yeah. So as you can see, we have a here we have two, we have a three L1, L2, L3 cache. Okay, so this is how it's look like. It is greater and it is greater than, as you can see, it's 320 KB, it's 5 MB, it's 8 MB. Okay, so this is how my RAM is my slowest memory. Okay, in this. So this is the basically architecture which it's basically working on core 1, core 2. It may work on a same core. Okay, so for this is a race condition. How to solve this race condition basically? Okay, so let's see. We have a critical section. What does this means? Okay, what does this means? We basically, let's show in the code. Let me delete this again, rewrite this. Yeah, so what this is means, we have a mutex, which is a mutual exclusion. Okay, mutual exclusion. So basically when we are running on thread T1, suppose we are running on thread T1 is running on my core 1. Okay, and it is acquiring me a resource in a main memory. It is acquiring a resource name a shared variable, which is value of 1000. Okay, so what mutual exclusion means here? So mutual exclusion means here is when we basically running on thread T1, which is running on core 1. Okay, so it will lock the memory. It will lock the memory. It will lock the memory until this for loop ends. Okay, until this for loop ends. So what does it means? Let me show you an example. Let me write it. So here I have written m.log, m.log, and after that m dot unlock. Okay, m dot unlock. So what this m dot lock m dot unlock means, suppose my variable, for running a loop, it will in it will firstly read the variable which is 1000. After incrementing first variable which is 1001, it will still lock the memory until it write it into my shared memory. Okay, 101. After this, what we can say, let me write up this. Yeah, here. Okay, after writing this, it will unlock my memory. Okay, it will unlock my memory here. So that what does it means by mutual exclusion? Okay, we created here a mutex. Let me uncomment it. Yeah, so this is what means. So let me run it again. Yeah, it's giving me 3000 as my answer. Let me run it again. So again it's 3000. Whenever how many times I run, it will always give me 3000. Not like previous time I am getting 2999 or 2998. Okay. Every time I run this code, it will give me the correct answer. Now, due to mutual exclusion, I lock the memory. Okay. So whenever it's read and write until it does not free the shared piece of memory. Okay. So now here comes a tricky part. Sometime our code, let me rub this again. So yeah, sometime our codes become some lengthy. Okay. This function starts, I am accessing some variable. Sometime I forget to basically lock and unlock. So I put a lock, but I forget to unlock this memory. Okay, so it's lock the memory forever. Okay, so this is how lock and unlock means. Okay, sometimes I forget whenever my code is lengthy. I misforget what is put to m dot lock. Okay, m dot unlock. So to solve this problem, we have a called log guard. Called log guard is basically a class. So we will talk about this in the in the upcoming minute. So basically log guard, what does it do? Let me comment it. Let me comment it. Yeah. So what does it do? It basically means whenever, suppose I have a piece of code here. This is my function. This is my variable which I am working on. Just say s. Okay. Whenever my s variable goes out of scope, okay, so this m dot logguard frees the memory, unlock the memory. Okay, it will lock whenever it's come into the scope variable s, and after it goes out of the scope from the function, it will unlock my memory. So let's try to run this code again. So yeah, it's giving me same answer. Let's again try. Yeah, it's giving me same answer. So this m dot logguard means. So let's try to understand it more. So yeah, so logguard is basically a RAII object. RAII means resource execution. Execution is initialization, basically a scope bound resource management operator. So what it does is means resource means here resource means any memory, file handling, socket, database handling. Okay. So scope bound means lifetime of a object is bounded to a scope of a variable. So that variable goes out of scope, the deconstructor releases the resources. So whenever my scope goes, basically my variable goes out of my scope, it will call the deconstructor and releases the resource which I acquired for the lock. Okay. So this is what logguard means. Now let's talk about deadlock. So deadlock is basically two or more processes or threads are unable to process because they are each waiting for other to release resources. What does this mean? Let's see. So yeah, let's see here. Yeah. So again, this is for thread, this is for mutual exclusion. Chrono is for time, basically when we are dealing with time. So I will show you for that. So we created here two mutex, okay, mutex m1 and m2. So in my main function, I am creating a thread t1, I am creating a thread t2, okay. Again, after it's joining its synchronization, I have put join. So what does thread t1 and thread t2 do? Thread T1 is basically locking my resources M1, okay, locking my resources M1, and it will put some sleep for 1 millisecond. Again, it will comes to what we can say lock 2. Again, it will lock the resources. After it unlock the resources, because we are using here lock guard, so we does not have to put unlock and lock here. So yeah, so again it will put a lock on M2. So here you can see, let me correct it. For that lock we are acquiring M2, here we are acquiring M1, okay. So yeah, here we are acquiring M2. So first of all, in process 1 we are acquiring M1, in process 2 we are acquiring M2, okay. So this is the condition where the deadlocks occur, okay. So since we are acquiring a resource, let me draw a diagram. Thread 1, this is a resource 1, okay, this is resource 1. Let me draw it clearly. So we have a thread 1, we have a thread 2, here is it's a resources 1, here is a resources 2, okay. So thread 1 is acquiring resource 1, thread 2 is acquiring initially occurring resource 2. So after some time, millisecond, resource T1 needs resource T2, okay. Because it is acquired by T1, it does not get any anymore, okay. Since T2 wants to resource T1, it is acquired by T1, so it didn't get it, okay, didn't get the resource R1. So when we run this code, let me run this code, let me select this language, uh, let me run this code again. So here run me this again and run it again. So as you can see here, as you can see here, I'm not getting any output. Because why I'm not getting any output? So because here I am printing something, but it is not printing here, okay. So because it's actually ended up into a deadlock where lock basically what we can say here, process P1 thread T1 is requiring lock M1 and waiting for the lock M2 to get released from here, okay. So because it is not releasing, so it's get into the deadlock. So let's try to fix this. How can we fix this? Let me rub this, stop the code. So here it is a condition, whenever we are locking, we have to lock one process and release one process, okay. So we are not end up into a deadlock, okay. So suppose let's make a diagram. So let this is my thread T1, this is my thread T2, okay. This is my resource 1, this is my resource 2, okay. So what does it means? Basically, when I am acquiring a resource 1, thread T1 acquiring resource T1, at the same time, thread T2 wants to acquire the resource 1. Since it is not free, it does not get any resource 1. After that, my resource 2 gets to wants to acquire resource M2, basically resource 2. So since it is free, it will acquire this resource, and after acquiring these two resources and releasing it, it will print me the output. And after that, my thread T2, when the resource 1 free, it will get acquired by thread T2, and resource 2 when free, it will acquired by the resource thread T1. So let's try to run this code again. So yeah, as you can see here, process 1 has acquired both the locks, process 2 has acquired both the locks. As you can see here, now there is no deadlock condition. Okay, so this is how to remove a deadlock in a simple program. I have shown here also. The solution is predefined order strategy known as resource allocation graph or log hierarchy. Okay, so to remove the deadlock. So I think that's all. That's all from me. So thank you.